everyone. So today what I'd like to do is talk to you about half-life problems. And these take a little bit of logic and a little bit of math, but I find that I actually enjoy doing them because I'm not having to do, like, there's not a specific formula. We're just kind of using our brain to kind of figure it out. So in this one, we say that radium-226 has a half-life of 1599 years, and then we want to know how long until only 1/8 of the sample is left. And so here's what we're going to do. When we first start, we have 100% of the sample, or we have, 1/1. Then we have 1 half-life. We'll have half the sample left. After the second half-life, we will have 1/4 of the sample left. Do you see how we're doing? This is doubling down here. So after 3 half-lives, we'll have 1/8. Okay, so this is the 1/8 that we need, but now we need to know how long. So we have 3 of these arrows. So we're going to do 1599 times 3. So our answer is going to be 4797 years. Okay, and so that would be our answer. And so let's try another one. Now we have another problem. It says the half-life of iodine-131 is 8 days. We still want to know how long until a sample decays to only 1/4 of the original amount. So we're going to do something kind of similar. So what I suggest that you do is pause this video, see if you can work it out yourself, and then once you've got what you think is the answer, come back and see if you're right. Okay, and I'm just going to go ahead and start working on it. So again, our very first, in the beginning, we have 1, and that's 1 half-life. After 1 half-life, we have half. And then after 2 half-lives, we have 1/4. So that's what we need. So then we're going to take our 8 days and multiply that by 2, and that's going to give us 16 days. So what do you think? Did you get it? If you didn't, where'd you go wrong? And let's try and do it again. Now, this one is a little more difficult. This is more like a real life problem. So we're going to work through one of these. And this is more like what you would see on the AP exam or on your test. So a sample of radioactive isotopes was released into a lake. The isotope has a half-life of 5 years. If the initial amount was 100 grams, how much remains after 15 years? Okay, so here's what we're going to do. Same kind of thing, except in starting with a 1, we're going to start with 100 grams because that was our beginning amount. Okay, and then for my arrow, I'm going to put 5 years because that's the half-life. And after 5 years, I'll have 50 grams, right? And this arrow is another 5 years, so you could put another 5 years, or because this is kind of an easy number, you could also put 10 years because it's 5 plus 5. So maybe here's how we'll write this so you don't get confused. We'll do 5 years, 10 total. And then the next one, I'm going to do 50 divided by 2 is 25 grams. Okay. And then we're going to have another 5 years, 15 total. So this will be our correct answer, whatever it is. So 25 divided by 2 is going to be 12.5 grams. Okay, so after 15 years, 12.5 grams remains. If this is an FRQ, you don't have to show a real formula. You can just show work like this. That will count as showing your work on the FRQ. And if it's the multiple choice part, you don't have to show your work. So hopefully this helps you understand how to calculate a half-life problem.